So this is what we're going to be working towards with video samples that we gathered the other night. Recall that we gathered 5 AVI video files, actually the SER video files, each one of which is 6 gigs in size. And we're going to use the data content of those files to create this image. Okay, so this is what we're going to be striving for. I've already gone through that data, but I'm going to go through it with you now. In this session, in this second of a 2-part series. This is the processing of the data video. The previous one was the capture of the video. What we're going to do is download a piece of software called Autostakkert. This is a very powerful piece of software. It's completely free. It won't cost you a penny. It is a very small and lightweight application. I always use the 32-bit version. It works perfectly well for the purposes that I need. Bearing in mind that a 32-bit application can only use 4 gig of memory on a Windows system, it's not an issue. So it's a very lightweight application, completely free, and it works really well. So what we're going to do is download that and install it. So you're going to download the application Autostakkert, and you'll see these files when you uncompress the archive file. Now there isn't actually an installer with Autostakkert, so what I normally do is I get these files, and what I do is I drag them across to my programs files. I create a directory called Autostakkert, then there I drag these files into this directory, and then what I do is I create a shortcut to that executable, and then I can run Autostakkert directly from the desktop. So yeah, just bear in mind that there is no actual installable routine with Autostakkert. You just do what I've said there. So what we're going to do next is we're going to get the software running, and then we're going to take it from there. Okay, so I've double clicked Autostakkert to open it up, and it brings us up these 2 windows. It brings us up in the configuration window on the left hand side, and it brings us up the frame view window on the right hand side. We do most of our configuration in the left hand window, and then there's a few little bits and bobs that we need to do in the right hand window as well. So if you recall the other night, what we did is we captured some video files of the moon. We want to get one of those and just drag it over to the configuration window here on the left. What we could also have done is we could have gone file and open AVI or SCR format file. So you can capture, remember, if you recall, we discussed that. We can capture in either AVI format or SCR format. So first things we need to do is we need to configure this left hand window. And for any imaging sessions of the moon, we always want to choose surface. Actually, the moon or the sun for that matter. Yeah, the reason for that is that these are large bodies with a lot of very refined detail on them. And planets are very much smaller. They'd be a tiny little circle, nowhere near the detail that's being displayed here now. What we can do here is play that video file back. Can you see it there? How it's being played back, and it's shimmering around. And what's happening, look at the shimmering of the moon compared to this X here. Can you see? Yeah, what we've got to tell Autostakkert to do is to align, let me just press stop, align every one of those 3000 frames, align them all to a common anchor point. And we define that anchor by doing a control click, and we normally do it on a single feature that's only contained within the moon. So for instance, we could go alt click on this bright crater here, sorry, control click, I beg your pardon, control click on that bright crater here, or for instance we could go on this one over here, look, control click. What we always want to try to make sure is this box is always contained within the body of the moon. So we could control click on there, for instance, if we wanted to, or wherever we want, wherever we decide we want to click, but make sure it's within the body of the moon. And what Autostakkert is then going to do is it's going to align each one of those shimmering frames, which we can see, it's going to align them precisely to that X, and it's going to rank the frames, ranking them down from 100% for the very best one down to 0 for the worst one. And it will do that completely automatically. We don't have to do anything at all in order for it to do that. So remember, at this stage all we've done is we've opened a file, we've put in the surface option here. I also like to click improved tracking as well. I find that gives me a slightly more accurate result at the expense of slightly increased CPU of your computer. And then all we do is just click analyze, and then the program goes away and it goes through all of those 3000 frames and it ranks them and aligns them with that anchor point that we just discussed. So once that's done, I'll be back. So Autostakkert took around about 35 seconds on this particular computer. This is an Intel i7 8700 computer with 32 gig of memory. You don't need a computer as that powerful, but the more powerful, as is the case with all of these things, the more powerful it is, the quicker it will get this stuff done. And what it's done is it's now aligned all of these frames together. This red box here is minimized and eliminated the wobble. So this is all self-contained within this red box, and it's ranked the frames. So what I can do now is this frame here at the beginning of the video is the highest quality video frame in the entire 3000 frame sequence. It's been given a ranking, and I'm sorry I can't zoom in on this, hopefully that you can see this. This has been given a ranking of 100%, the very best one, and it's frame number 122 out of 3000. You will see that when I move this slider, we rapidly drop off. Okay, so for instance, I'm only 4% or 3.9% there into the total number of frames, 119 out of 3000, yet my quality has dropped down to 85.2% already. That quality is not an exact number. It's a relationship number how to compare frames with each other. So for instance, what I like to do is I like to eliminate all frames that are worse than the top 70% or the top 30%. Everything below 70% quality number I wish to completely discard. So you can see that only 22% of the entire capture of frames, only 22% of them met my threshold of being over the 70% quality. Most of them are rubbish, or not as good. Yeah, they're not as good at all. That's the worst frame, is frame number 1711. It's still not bad actually, but it's not as good as the top frame. Look at the detail in the top frame, the best one. So what we want to do is make sure that we only select the best frames to stack on top of each other. And I have a general rule of thumb on a night of reasonable clarity of the atmosphere, and this night was reasonable. You know, if I play it, it's okay. Right, now look how it's getting wobblier as we're getting in lower down the quality of frames. Yeah, this was not a bad night really, but the worse quality we get, we don't want these frames to contribute towards the final output of Autostakkert for this particular video. We want to create a video of this segment of the moon only from the best frames. So on a poor night, for instance, this is not a bad night really. On a poor night, the moon can literally be jumping around like jello. It really can. It can be terrible, and sometimes you'll only have the top 1% of frames to be able to keep. This night here, I think I can go down to about 30%. This is very subjective and comes with experience to some extent, but as a general rule, if the moon is pretty clear in the sky, about the top sort of 25% of frames, use those to stack together. And we can see this quality graph here as well. This gives us some information. You can see the green bar moves here when I move this slider across. Yeah, giving me an indication of the quality. So for instance, when I started my capture, there was about 10% in, which corresponds to what I said earlier on. There were very, very good frames. Then we've got some rubbish frames down here, look, and really bad ones there, and then some good ones later on in the capture. Then we had some bad ones again. What I'm saying is I only want the top 30% of quality of frames, which transposes to only 25% of the total number. So I hope that makes sense. It's a little bit confusing because we're talking about two percentage numbers. The percentage in terms of the quality of the frames, and then the percentage in terms of the number of them. I want most of the frames to be higher than 70% quality, and only 25% of the total number of frames meet that criteria. Now you could say, well, so what, Steve? What's this got to do with anything? It's actually very significant, because can you see this green box here? This is where we say I only want the top 25% of the frames to be stacked. That's what I'm going to say. I only want to choose the top 25% or top 30% of frames. You know what? I'm going to go with 25%. So I've entered my percentage of frames that I want to keep in that box there. I want to keep the top 25% of frames. Now what I'm going to do is I'm going to give Autostakkert some more alignment points, because what it's now going to do with those 25% of the frames is it's going to stack them one on top of each other. So what we need to do is create an alignment point grid, and we do that by pressing this Place AP Grid button here. You may need to fiddle around with the number of APs here, or alignment points, and you can draw them yourself if you like by pressing manual draw and just clicking if that's what you want to do. Yep, I don't bother with that, generally speaking. What I do is I let Autostakkert choose the alignment points automatically, and we want to make sure that they're all within the body of the moon. Now, the number of alignment points that it chooses depends very much, and we've got 222 here. Look, can you see here? It depends on these parameters here, the size of the alignment point. If I clear, now place the alignment point grid again, because I've got an alignment point size of 200 now, yeah, there's less alignment points. Conversely, if I choose 24 and place the AP grid, yeah, there are 5,000, and that's far too many. I don't need anywhere near that amount. So I'll press clear again, and I'm going to go with around about 104, a size of about 104. Just play around with this. Get yourself to a point where you've got around about 250 odd or 300 alignment points. And then what Autostakkert will do is it will use those alignment points to create the reference by which it will then stack those 25% of frames which we've selected in the previous step. So we've defined our alignment points. There's a couple of more things we need to do. So first one is, do we want the final result to be sharpened? What can happen, and what we can tell Autostakkert to do, is use something called the wavelets that are, this is an image processing technique, and you have wavelets in any photograph, any digital photograph, whether it's of the kids, whether it's of the dog, whether it's a landscape, or whether it's of the moon here. Yeah, wavelets are the vehicle by which the structure of a digital image is composed, and there are wavelets for large structures and there are wavelets for very tiny structures. Now what we can tell Autostakkert to do is to try to sharpen the resulting image. After it's done all of that stacking, it can use the wavelet sharpening technique. It's sometimes called deconvolution, or like a multi-scale linear transformation process. That's a bit of a mouthful, isn't it? But it uses that to try to sharpen the final image. So what I normally do is I leave this as default. Yes, I want it to be sharpened, but if you over sharpen it, it can tend to look a little bit unreal and a little bit posterized, like an Andy Warhol picture, if you like. And we don't want that. So what we're saying here is, yes, please sharpen it, but what we want you to do then is to mix the sharpened result 50% with the original stacked image. So mix it, and then that will tend to give us a slightly more natural look. What I also like to do is I like to enable what's called the drizzle technique. Again, this is a well-known technique in astrophotography, and it was developed for images from the Hubble Space Telescope. And what they found by certain mathematical techniques is that they could derive more data, or a sharper image, from a set of data than is actually contained within that data. It sounds almost crazy, doesn't it? It sounds almost too good to be true. but you can, by various mathematical techniques developed by NASA, you can actually get a sharper result by using this thing called a drizzle technique. And there are all sorts of academic papers on the internet to read about this if you can't get to sleep one night, right? So what I always do, and to keep it short, I just set the drizzle to 1.5%, and as I said before, I leave the blended raw 50% with a sharpened technique, and I'm doing the top 25%, and the result of all of that is going to spit out a TIFF file, right? And it's going to put it in the directory from which the master AVI file came from. So it's going to create a directory in here. Okay, so what I'm going to do now is hit the stack button, and it's going to go away, and it's going to take about 2 minutes to do these processes, and then I'll pause the video and we'll be back. Okay, so we're back. The first thing I want to show you over here is the CPU utilization of what we've just done. Look, we have basically maxed out 12 threads on my computer, an i7-8700, which is in 2019 when I'm recording this. It's not the absolute top end processor in the sort of like commercial range, but it's a pretty high CPU, and it makes it basically max that out. And I have seen four physical CPUs, each with 16 cores. In other words, a total of 64 cores. I've seen one of those completely maxed out, depending on how many of these alignment points you have and how long the video is. So it's very CPU intensive. So what we did is we ran this process, and we can see here the processes, the sub processes that ran. I mean, look how long the image stacking took, 46 seconds. Yeah, we aligned everything with a reference image, 25.9, so you can see yourself there. So it took us a total of about 2 minutes to create the result. And what it did is it spat out a directory in the container directory where we had our video files. And it's created what we call Autostakkert P25. Why P25? Percentage 25. If we did this again with the top 30% of frames, right, the directory then would be ASP30. If it was 38% of the frames, it would be P38. So you get the idea. So let's open that directory and let's have a look what we got. After all of what we've done here, what have we got? Well, let's have a look. Let's have a double click. So this is the output with all of that stacking that we did, and just with drizzle. No sharpening, just with drizzle, and it's not bad. Yeah, we've got some nice detail there, so that's okay. And we can sharpen that at a later stage if we choose to do so with something like Photoshop or any other program that you may have for image manipulation. So that's nice. I like it. That's good. But we had two files. Let's have a look at this one. Now then, doesn't that look good? So this is where we've blended the sharpened image. We blended it. Can remember, let's go back here again. We can see here we blended it 50%, yeah, with the original non-blended, and we've got some really nice detail here. We can see some really nice sharp features, and that's pretty good, and that gives us the basis from which we can create a really nice, I mean, look at all these rays emanating from the crater here. We can see the shadow in the craters coming from the sun, so clearly the sun is shining that direction, downwards to the 7 o'clock, 8 o'clock position. That's nice. I like it. So after all of that work, we have got that segment of the moon. Remember, and I'm not going to do every single one of these with you, but we now need to repeat this process for the other videos that we captured. Yeah, because we need to create videos for the entire sequence of the moon, the entire surface area of the moon. So if I go back to my documents again, and I look, I've now got to repeat this for these other videos. When I've done that, what I like to do is I like to copy the master file here, and I've already done this for these videos, and I copy them into what I call my master set. So from this set of videos, I am now going to use some other software to create the final image, the composite image. So for instance, I repeated this on this other video, which we've got more of the north of the moon in there. And I also repeated it, for instance, for the top part of the moon. So we now got a sequence of sharp, still pictures from which we can blend together. And these pictures were created via this Autostakkert program. So we've finished with Autostakkert. We've created all of our images from the videos that we took. And now we're going to move on to the next step. So we've finished with Autostakkert. We've got our series of master files. And now we need to glue those together intelligently to create what this will be, a final picture of the moon. Now, how do we do that? There are two ways we can do it. Well, actually, there are multiple ways we can do it. We can use it using something like Photoshop, and I will show that option a little bit later. But we can also use a completely free piece of software from Microsoft. It's called the Image Composite Editor. Just type in Image Composite Editor in Google, and this page will pop up. So let's launch the Image Composite Editor. Excuse me. So we'll launch this piece of software. Okay. And we're going to create a new panorama from images. We could do it that way and open the images up. Or what we can do is we can just get the images. It's these 5 over here, and just drag them over into Image Composite Editor. And there they are. Now what we're going to tell the program to do is to stitch them together to create a composite. Just press the next, and it does its magic in the background. Doesn't take long, and there we go. Just like that, pretty amazing. Okay, do we want to crop? No, we don't want to crop. We can ignore this, and all we want it to do is to export the file. Now, I think that's pretty impressive from a completely free piece of software. We can do something similar in Photoshop, and Photoshop, to be fair, is slightly more powerful, but you know what, this is pretty brilliant. It does 98% of what the Photoshop stitching feature does. It's very good. Now that could stand in an image, of course we could tidy up the edges of it a little bit, but that in its own right could stand as an image in its own right, as a fantastic picture of the moon. We can export it. Of course we want to export it at 100% quality. Yeah, and we can export it to the disk, and we can save it as a JPEG or a TIFF or whatever we want to do. So that will then be our final image of the moon. But there are some other things that we can do as well. And we can replicate what we just did there with Photoshop to create a very similar result. But with Photoshop, we can go on and do some further processing. So we discussed the use of the Image Composite Editor, the free piece of software from Microsoft, to stitch those individual master files. You know, we stitch those together using Image Composite Editor, which is great, and it's completely free and brilliant, and it works great. But if you've got Photoshop, I have, because I use Photoshop extensively for photography, not just astrophotography, but many other purposes as well. There's some great things that you can do in Photoshop. So this is, having just opened Photoshop, what we can do is go to File, we go to Automate, and we go to Photo Merge. And it opens up this little dialog box. Okay, we want to leave this as default, auto. Yeah, unless you've got very specific reasons to fiddle around with these other things, don't, just leave them alone. We're going to browse for our files. So we're going to go to where my files are stored for this, my master files, the output from Autostakkert, recall. Our master files here. And my master files are these ones in the middle. Ignore these two at the end, these are my final result. Yeah, these are these 5 in the middle here. These are the output files from Autostakkert. So we'll select those. Now, we want it to blend the images together. Of course we do. That's why we're doing this. I always like to click the geometric distortion correction as well. It's a good habit to get into on a data set like this, where the images are very large scale. You know, basically the entire moon. It's not going to show a great deal of difference. But if you add a tighter more zoomed in look, and you had lots of images of a different scale, i.e. you took some pictures with a zoom telephoto lens and some others were with a wider lens, then you need to have geometric distortion correction enabled. I just click it as default. So we've got a files collected, we've got these two collected. This is default. We'll click OK and watch Photoshop work its magic. So you can see that we've got the we can see the hourglass thing going around as it's thinking about it. It's stitching them all together. It's taking a while to do it because there's a lot going on here, and it's going to merge the seams together so the seams are not visible. And there's our final result. Okay, so I think you'd agree that to the casual eye, there's not a great deal of difference between this and Image Composite Editor. I can see a little bit of difference actually. There's a bit of difference. Photoshop does it slightly better around the limb of the moon, the edge here. We've got less sharp edges, but you know, it's still pretty damn good. So that technique is using Photoshop to do that merge of the images to create this mosaic. What we could do if we wanted to is turn off the individual layers that compose this image, and we can see which contribution each one of the layers is making to the final image. So this one here is contributing very little, whereas this one at the bottom is contributing lots, the whole top look. And these 5 layers, yeah, are collectively making up the entire image. So I've gone into full screen mode now, just so you can see what I'm doing a little bit more clearly in Photoshop. And to be honest with you, there's not a great deal I'm going to do really. We're going to brighten up the details a little bit more and enhance the details, and we're going to get rid of some of this rubbish around the edges, and we're going to reduce the noise a little bit. Before we do any of that, first thing we want to do is to take the layers, the 5 layers, and just merge those together into one layer. Yeah, we're happy with this picture. Now we'll merge the layers together, and the whole moon now is represented by one layer. Now what I'm going to do is now duplicate that layer. So I can do, we'll call it layer 1 crop, and we can now do what we want with this layer without destroying or risking destroying our original picture that we created a few moments ago with the photo merge. So the first thing I want to do here is crop this image. So I just select the crop tool at the top here. And again guys, I'm sure if you're familiar, you may be more familiar with Photoshop than what I am. I'm not an expert at it by any means. Let's just do a nice neat crop and get rid of all the stuff around the edges, and click tick box there, and there we go. We've got a nice crop of the moon there. Now that again, that would stand as a picture in its own right. That's a nice picture, but there are a few things that we could do to improve this. We can bring out some details as I mentioned earlier on, and we can reduce the noise a little bit. So following the best practices, let's create another layer. So let's duplicate the crop layer we just created, duplicate layer, and we'll call this enhance detail layer. Call it what you like really, but we'll just call it that. So how we're going to enhance the detail. One of the fantastic capabilities of Photoshop, or one of the thousands of fantastic capabilities, but this one is really nice, is just the camera raw filter. So just go to your filter menu, camera raw, and it will open up the camera raw menu, and there we go. Have a little think about that. Now when we use camera raw, we are only working on a copy of the original image. We are not working on the original. What camera raw does, it takes a copy of it into memory, and this is why Photoshop can be very memory intensive on a system. It gets a copy of this picture, and we're going to manipulate the copy. All right, and one of the other things I like to do is just click this Y here at the bottom. You can see where I'm clicking to create a side-by-side view, and that side-by-side view I can zoom in as well if that's what I want to do, and spacebar pan around here, just pan around the moon a little bit. Where do I want to look at? I want to zoom in. I want to have visibility of these two these two, what we call seas of the moon here. They're not actual seas, they're lava plains. This is the Sea of Tranquility. In fact, if you're interested, the lunar landing, Apollo 11, was just here, between these two craters and this one here, just about there. I like to have a side-by-side view, and then what I like to do is just to give this a little bit of dehaze, a little bit, emphasize that, a little bit of dehaze, between sort of 20 to 30, something like that. Notice how that's brought out that clarity a little bit more, that it's brought out the contrast of this surface detail. Double click there to take it back if that's what we want to do, but I like to have that around about 25, something like that. And another good one is the clarity, which has dragged that one over a little bit as well. I mean, you can go too far with it like that, and that looks too posterized, like an Andy Warhol picture. Again, as is always the case with any form of digital image manipulation, it's all about doing little bits. Maybe a little bit on the, I'd like to see the blacks in there a little bit more. Yeah, to bring out some of the bit more detail there as well. It's just very subtle and very subjective as well. I mean, you know, at the end of the day, guys, it's your photo, right? And it's how you want it to be presented, what you want, how you like it. Yeah, we can fiddle around with these. You know, you can go too far, you can just fiddle around with them. But for the interest of this video, I'm going to say I like that. Okay, actually, I do like that. I think that's quite a nice rendition. Let's go before and after by pressing this one here. Before, after, before, after, before, after. I like it. That's good. Okay, and we could be more scientific with the histogram up here and all sorts of things if that's what we wanted to do. We're keeping this simple, guys, right? So now what I want to do is I want to apply the details from Camera Raw, and I want to now apply it to the main image. Do I really want to do this? Yes. If we screw it up, does it matter? No, because we created that layer, remember. So click OK. And that's our result from Camera Raw. If we want to turn off that layer, we can do just by pressing this I button here, look. And that's the original picture, and that's with Camera Raw. Original Camera Raw. So Photoshop has some powerful tools to be able to do this manipulation of these images. So I like Photoshop. I think it's a fantastic thing to have if you're a photographer. You can get it on one of the lower priced Adobe Creative Cloud plans for sort of like £9 or $9 a month. It's not a great deal of money. It's a couple of beers a month. To me, it's worth it. You know, guys, you will make that call on your own, right? But I think it's worth it. So let's go back to the zoom tool, Z or Z. Let's come in here and have a little look. Now that's looking nice. Spacebar drag with the mouse, and we can look at some nice surface detail. I mean, look at this, where this thing here struck and left those rays across the moon there. And again, whoa, that's going way too far. Way too far. So alternate click to take us back out again. In and out. So let's come back out again. And again, as I said earlier on, this is the Apollo 11 landing site here. Apollo 17, the last lunar landing in 1972, was about here, the Taurus Littrow Valley up here. So I'm pretty happy with that, and I think that's looking good. But there's one more thing we could do. So zoom in a little bit more again, and I'm going to go up to filter, and I'm going to go to noise and reduce noise. So there is a little bit of a noise in that background there, and I can use this tool to minimize that, and it gives us what we call a preview in the window of what we're going to do. And I like to leave this entirely at default, and by all means feel free to fiddle around with it if that's what you want to do, but I leave it at the default settings. You know, Adobe know more about image processing than what I do, right? And the default settings are generally okay for lunar photography. So all I did was open up the reduce noise tool from the filter menu and click OK. Okay, now you probably didn't see a great deal there, but if I go edit, undo and edit, redo, there's a very subtle change that takes place. Undo and edit, whoops, redo, edit, redo, reduce noise. Undo, look at this detail around here. Look in that area there, guys. Look in there. Not there. Sorry. Look in here. when I undo the noise reduction, undo noise, keep looking. Can you see more of this noise comes back? And if I redo it, keep looking there again, redo, reduce noise, it goes. So I'm happy with that. I think that's about as far as we can take it. We're quite zoomed in there. So alternate and click to come back out again. Spacebar, drag. I think that's pretty good. Spacebar, drag. I think that's pretty good. If we wanted to share our image now, what we could do is we could drag out the type tool here. We could click down there and we could go the moon. Whoa, moon, that's it. The 15th of Feb 2019. We could put a name on it if we wanted to. And then, yeah, that's it. Now, looking at that very objectively, with a very, very critical eye, I would say that that has been probably fractionally over sharpened. Now we can do some, I'm not going to do it now guys, I think it's enough, but we can reduce that sharpening if we wanted to do so, just to take it back a little bit. I think it's just a fraction posterized, but I'm splitting hairs. I think from an amateur person in their backyard taking these photographs, I think that's pretty good. What I could have done also is I could have used a different telescope and had a more zoomed in look and focused on a particular area. For instance, around some of these craters like Aristotle and Copernicus and things. Yeah, we could have zoomed in on just that one area and made a subject out of just one crater or one part of the moon. For instance, I know that some people, pressing Z here and zooming in again, I've made this point already, space bar down a bit. Some people might want to do a bit more of a study of the Taurus Littrow Valley over here, for instance, where Apollo 17 landed, or maybe, you know, you might be interested in Apollo 15 over here at Adley Rill. You know, whatever floats your boat, really. But yeah, I think that's it. I think we've taken that as far as we can, and I'm quite happy with that. Now, one of the things I want to before I finish off on this two-part series, one of the things I want to make clear to people is that they could think or be tempted to think that, oh, you know, I don't have an expensive telescope. You know, Steve's talking about his Tech 140 refractor and, you know, his expensive camera. And, you know, you can do this with a DSLR, guys, right? And a telephoto lens. You can get some great results. If you've got a telephoto lens on a DSLR, the most important thing is to have a tripod to keep the camera still and have a remote shutter release. But you can create some great results. So you don't need really expensive top-end kit to have a go at this. And I won't want anyone sitting there thinking, you know, I'd like to have a go at this sort of stuff, but oh, it's out of my reach, because yeah, it's not cheap, but you know, by the same token, it's reasonably accessible. And I think it's great. So I'm going to do more of these videos as well. I think I'm going to do some more focused, concentrated in looks on some of these crater fields, and maybe, well, as we're getting near to the 50th anniversary of the first lunar landing, I might do a bit of a study of this area of the moon here, because when you zoom in a lot more on here with a higher resolution and more powerful telescope, and powerful does not necessarily mean better in astronomy, by the way. This tech refractor I'm using is very high quality refractor. It's made for me by a guy in Colorado, and it's very high quality without being particularly powerful. What we could do is get a more powerful scope, and we will see then a series of craters going across here, and it's near one of those craters where Apollo 11 landed. So what I might do next, I might do a study of that and do some really close-up photography of that particular area. I mean, of course, you'll never see the lunar lander. It's far too small. Even the Hubble Space Telescope can't see that. You need to be much nearer. But yeah, so I think I'm probably rambling on now, guys. I hope you found that useful. Again, feel free to comment and pass any constructive remarks in the chat. But thanks for watching, and I'll see you on my next video.